this video, we're going to look at different voting methods, different than like what maybe we have seen here in America. Some places are starting to do what's called ranked voting, especially like smaller elections where there might be more candidates running and not just two people like how we kind of see. So the ranked voting allows the idea that we can then instead do a ranking of our preference of candidates. So it's not an all or nothing scenario. That means a candidate who maybe may not be everybody's first choice could be a lot of people's second choice. And therefore, they might end up winning in a ranked voting situation. So let's kind of look at some examples of this, and we'll go through the different ways you can tally and calculate who wins in a ranked voting method. Okay, so let's say for simplicity, we have some students who are voting for their class president. The candidates are Omar, Anne, and Helena, which we're just going to use the letters to represent them. And what we have are all the votes, all the people who voted, and their rankings. Now, when you do something like this for a city, you would obviously have a computer kind of do what we're about to do. But we're going to do this by hand just to kind of see how the methods work and understand what everything is representing. So what we're going to do is make a preference schedule. And a preference schedule basically groups up who voted the same. So it groups who voted the same. So we're going to figure out how many people ranked them the same way, because there's a limited number of ways of ranking the candidates. Okay, so let's start with Vian. Vian ranked them Anne, Oscar, Helena, and looking at all the rest of them, nobody else ranked them that way, only Vian. So one person, so I'll put the one at the top, that's going to be the people who voted this way. So people who voted this way, that's going to represent how many people did this specific ranking. So Vian did A-O-H. Okay, so looking at Anne now, Anne ranked them Anne, Helena, Omar. And it looks like Eve also ranked them that way. And so did Jimmy. So three people ranked them A-H-O. Okay, Marv ranked them O-H-A. And it looks like Omar also ranked them that way. And so did Dave. So three people ranked them O-H-A. And then Tasha looks like she did it H-A-O. And so did Lupe. And so did Helena. So again, three people. H-A-O. And I can make sure that I got all the votes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There was 10 people who voted. And I can see when I total the numbers across the top line here, these numbers total up to 10. All right, so there we go. Let's look at the different ways of actually counting these ranked votes. Now, one way is the plurality method, and this is kind of the most basic of them, and it's the idea that the first choice wins. So it kind of disregards the rankings. Really, it's not allowing for the rankings to play in. I just repeated the table. It's just same table. I just wanted us to go through where this came from. Now that we understand where it came from, we'll just use it in this example. So we're going to figure out who got the most votes. So it's the most votes wins. All right. So let's start. It looks like we'll start with Anne. So Anne got one. So I'm looking at the first choice only. So here I'm looking at this row only. So Anne got 1 and another 3. So a total of 4 votes for Anne. Omar got 3 votes. I think I called him Oscar earlier. What a dork. It's because I know an Oscar. And last, Helena got another 3. So there we go. Those are the votes. And then based on this, this would be our winner. So the winner would be Anne. All right, so there you go, the plurality method. Let's try this again. Different example, different ranking. This time we have 5 candidates, and the preference schedule is already made for us. That's so nice. So let's use the plurality method, which is first choice. First choice. And let's see who would win by just looking at first choice. So they just called the candidates A, B, C, D, and E. And looking at this, A didn't get any first choice votes. Okay. Let's see. B got 3 plus 4, which is 7, plus 2, which is 9. So B got 9 votes total. C looks like they got 4. D got 6. And E got 1. Okay, so based on this, B has the majority or the most votes. I don't want to say majority because we're going to address that right down here. How many people voted? So let's just total up how many people actually voted in this scenario. So 3 plus 4 plus 4 plus 6 plus 2 plus 1. So 10, 20. Okay, 20 people voted. And what would be needed for a majority win? So majority means over 50%. That's what majority means. So 50% in this scenario would be 10, right? But that's not enough for a majority. So to be a majority, you would have to add 1. So 11 votes would be a majority win. And winner B did not win by a majority, which is part of the problem with the plurality method. So how many votes would be needed to win in the plurality method? So if we were to assume that there was like a 5-way tie, because 20 people voted, a 5-way tie means that each person would have gotten 4 votes. So in order to have a winner by the plurality method, like a barely squeaked out winner, one person would need 5 votes. So 5 would be the minimum number of votes to win under the plurality method. Okay, so let's look at other methods. This is called the instant runoff method. It can be called the sequential runoff or single transferable vote. What's nice about this one is we do take into account the entire ranking. And from here on out, the next 3 methods we'll see take into account the rankings. So what we'll start with is same starting place. We're going to start with who got their first choice, what the first choice votes were. So from above, A was 0, B was 9, C was 4, D was 6, and E is 1. Okay, so here's how this works. What you do is you eliminate a candidate. I'm going to write this down. Eliminate a candidate with least votes, or eliminate the candidate with least votes. That's not how you spell candidate. With least votes. But then what you do is you transfer their votes to the next choice for the next rank. So you transfer their votes to the next choice. So in this scenario, candidate A got no first choice votes, so they didn't have a chance of winning. So what I'm going to do is go look at who voted for candidate A and reassign those votes. Well, nobody voted for candidate A, so there's no votes to reassign. All right, so now I'm going to repeat this process with the next candidate, the next lowest candidate, which would be candidate E. So candidate E got 1 vote, and that came from this person right here. And this person right here would have transferred their votes to candidate A. Well, candidate A is no longer in the running. So that 1 vote is now going to go to candidate D. So here's where we're at. Candidate D picked up a vote, and B is still at 9, and C is at 4. Okay, so now we repeat the process again. Lowest candidate. So C is now our low candidate, which means these 4 people, they ranked A next. Well, A is unfortunately not in the running. So then their votes go to D. Okay, well, D just picked up another 4 votes. And now D is at 11, B is at 9, and there we go. So D would end up being the winner in this scenario, because for the reassignment based on ranking, D ends up winning the majority votes. And it is an actual majority. This is literally what we talked about earlier. This is an actual majority. So that's kind of nice. This candidate really is more popular than candidate B by a majority. All right. So there you go. That's how the instant runoff method works. Let's look at what's called the board account method or the point system. So this one kind of assigns points based on their ranking. The very first point assigned always starts with the last choice. So you start by assigning 1 point to the last choice or the last place. So the 5th choice in this case. So our point system, I'm going to go ahead and just abbreviate PT. For anybody who's ranked in 5th, they would just receive 1 point, 2 points for 4th, 3 points for 3rd, 4 points for 2nd, and 5 points for 1. So depending on how many candidates there are, they'll change the ranking and you just start with 1 at the bottom and go up. Okay, so now what I'm going to do is I'm going to total each candidate based on how many points they receive for their ranking. So candidate A, and I'm going to start with the bottom. I'm going to start by looking at how many 1 point they got. That's how I'm going to total it up. You could start with the top. You could go 5 points and go down. No big deal. But I'm going to start with 1 point. So candidate A got no 1 point votes. Nobody ranked candidate A last. Let's see. 4 people ranked them 4th. So that's 2 points. And then in 3rd, they had 3 plus 6 plus 2. Wow, that's 11. 11 people gave them 3rd. And then A got, let's see, 5 more in 4th or for 2nd place, which is 4 points. And then no rankings in 1st place. Okay. So if you get your calculator, grab it. I actually did my totaling, but go ahead and total it. Make sure you get the same thing I did. I'm getting 61. Okay, now let's repeat this for candidate B. So let's see, 6 people placed B as their last place. Okay, so for next would be, let's see, 4 plus 1, so 5. 0 placed candidate B for 3rd. Oh, again, 0. Nobody 2nd. Okay. But we do know that for the 1st place, they had 9. Okay. So totaling that up gives me 61. So isn't that interesting? Candidate A, who had no shot in the plurality method or even the instant runoff method, tied with candidate B, who won the plurality method. Interesting, right? But that's just because candidate A seemed to be kind of the midway candidate, the one that seemed to get a lot of 2nd, 3rd, 4th. Nobody was really thrilled about him and nobody really hated them. All right. C, let's see. Okay, so they got 1 person voted for them in the last place, 2 people in the next to the last place, 4 people in the next one. And then let's see, 3 plus 6, 9 for 2nd place, and 4 people in 1st place. All right, so that gives us a total of 73. Okay, candidate D. So right now, candidate C is winning. They had some votes in pretty much everywhere, but they had a really strong showing in 2nd place. Okay, D had 1. Oh no, sorry, 2 in last. And then they had 3 second to last. And then they had 5 3rd place. And then 4 2nd place. And then 6 wanted in 1st place. And that totals up to 69. Okay, so right now, candidate C is winning. All right, let's look at E. E had, ooh, wow. Wow, a lot ranking E low. Okay, so let's see, that's 11. Okay, probably not looking good for E. And then another 6. Whew, ranked them second to last. Nobody ranked them in third. 2 people ranked them in second, and one person first. Okay, wow, that's harsh. So 36. So candidate E did not do well in terms of a lot of people were not fond of them. So in this case, here's our winner. Candidate C ends up winning. Excuse me. Okay, so that would be the point system where we kind of include everybody's opinions, and that kind of helps us pick a candidate. What that tends to do, though, is favor these mid-level candidates who maybe have a really strong showing in the middle. And maybe not everybody's first choice, but people are okay with them in terms of allowing them to win over others. Okay. Then we have the Condorcet method. It's French, which is a pairwise comparison. So what's cool about this method is we basically do runoffs by pairs. So we do runoffs by pairs. So we look at every pair of candidates and say, if these candidates went head to head, who would win? And we basically count how many times did voters pick one candidate over another? So it's the idea of if they did go head to head, who would have won? So here's what I'm going to do. I'm going to pair them all up. I'm going to write all the pairings possible, and then I'm going to figure out who would win. So here's the pairings. I'll start with candidate A, and I'm going to pair candidate A with everybody. So if A paired up with B, and then A with C, A with D, and A with E. Okay. So there's all those pairings. And then for candidate B, well, we already paired them with A. So candidate B with C, B with D, B with E. Then candidate C would be C with D, C with E, and then the only other pairing is D and E. Okay, so that's just me kind of writing it out so I can compare them. Okay, so here's what we're going to do. We're going to look at each time A was favored compared to B. Okay, so looking at this first column here, in this first column, I see that in this column, B was ranked higher than A. So that would not be a case that A would win. All right. In this column, this next column, A was ranked higher than B. Okay, so right there, A would have won in a head-to-head with B. More people preferred A over B in that column. Not the same in the next column. B is over A. Oh, but it's the same here. And it looks like it's also the same here in this last column. Okay, so that would be a total of 11 votes for A. A gets 11 votes. And then B would have the remaining. Since there's 20 votes total, that means B gets 9. So in a head-to-head comparison, A won. Okay, so let's look at the next one. So let's look at first column. A does not beat C. Second column, A does not beat C. Here, let me erase these while I'm doing this. Third column, A does not beat C. Okay, here we go. Right here, we finally have A beating C in that one, and A beating C in that one. So 3 times A beats C, which means 17 times C would win in this matchup. Okay, so I'm going to go through a little faster now and kind of calculate these. So A beats D, A beats D, A beats D, A beats D. So let's see, that totals up to 10. So this is a tie, and we'll talk about what we can do in that case. Okay, let's see here. A beats E, A beats E, A beats E, A beats E, and the last two it doesn't. So that would be 17 to 3. So in this case, A wins. Okay, so B to C, B beats C, B beats C. Here, B wins, and B wins here again. So let's see, that's a total of 10, and that means C would be 10, so another tie. Okay, here B beats D, B beats D, B beats D, and that's it for that one. So that totals up to 9 and 11, so D wins on that one. First one, B wins over E, B wins over E, B wins over E, B wins over E. Okay, so let's see, that's 13 times to 7, so B wins there. Okay, so this one for C, C does beat D here, and here, and here. So that totals up to 9, which D then is 11, so D would win. C beats E here, and here, and here, and here, which would be 17. So E gets 3. So there we go. And then last, D beats E here, and here, and here, and here. And that would give D 17 to 3. Okay. Oops, I just realized I put an equal sign. And I apologize for my dog. Okay. So there we go. So on the head-to-head, let's see, how many times does A win? So A wins 2 times. And then let's see, B wins once. And then let's see, C wins twice. And then D wins 3 times on these runoffs. So in this case, since D won 3 times, that would make D the winner on these head-to-head cases. Okay, now, if we were to include ties, in other words, in the case of a tie, we would count it as a half a point won by each candidate. So that's a possibility. So note, you could give half a point to both candidates in a tie. And if you did, for the tie, if we included it, A would then win half a point, and so would D. So that would mean A is 2.5, D would be 3.5. And then the other tie was with the other 2 candidates. So B gets 1, and so does C. They all get half a point. And so it still ends up D winning in this scenario, even with awarding half a point on ties. So that kind of solidifies that in a runoff, pairwise runoff, D would in fact be the winner in this system.